The structure of the DNA molecule was discovered by two scientists, James Watson and Francis Crick, in 1955. Their discovery demonstrated that life was much more complex than anyone had previously envisioned. Himself a confirmed evolutionist, Francis Crick, who received a Nobel Prize for this discovery, came to confess that a structure like DNA could never have emerged by chance.
So there's a big question if you're just kind of trying to assess how likely is it that we'd find a protein by chance with all the amino acids in that prebiotic soup interacting with each other for, say, billions of years. And I give it a lot of time. How likely is it that we'd ever get a protein to arise by chance? So I have a colleague who's been interested in the whole question of whether or not life could arise by chance for a long time. His name is Doug Axe. He's a molecular biologist. He did his PhD at Caltech. He worked for 14 years at Cambridge University, and he wanted to find out how common or how rare are the functional sequences of amino acids among the big space of all the possible amino acids there are. And he came up with a really amazing number, and it's 10 to the 74 power. So just to get the amino acid sequence properly, you've got an odds of about 1 in 10 to the 74. But there's other probabilistic hurdles that have to be overcome. If you want to build a protein, we know from chemistry that you have to attach the amino acids together with what's called a peptide bond. In nature, peptide bonds occur with about a 1 in 2 in a 1 in 2 frequency. Half the bonds that form between amino acids are peptide bonds, half aren't. But if you get any bonds forming that aren't peptide bonds, you can't form a protein. So to form a protein, 150 amino acids long, you've got a 1 in 2 chance at each site of getting the correct type of linkage. So you got 1 in 2 times 1 in 2 times 1 in 2 times 1 in 2 to the what power? Close to 150. Since we got linkages, we have 149, but call it 150, okay? So in other words, we got another huge exponential problem to overcome. So, and it turns out that 1 in 2 to the 150 is the same number as 10 to the 45th, 1 in 10 to the 45. So now we got two incredibly improbable things that we've got to overcome to build a functional protein by chance alone. Wow. Now, can anyone get their mind around a number that big? There's only 10 to the 80th elementary particles in the entire universe. There's only 10 to the 16th seconds since the Big Bang. There's only 10 to the 139th total events since the beginning of the universe. Now you're starting to get the understanding of why people are very skeptical that the chance hypothesis is going to do the job. Now, you may have heard just the opposite. Has anyone ever gotten in a discussion with you about the origin of life and said, hey, it happened by chance? I mean, do you hear that? I mean, this happens to me. I'll be lecturing in hostile university environments, and I'll get done and somebody say, well, but, and they want to argue with me about the probabilities. And I just shut the discussion down because I say, no serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened.
Darwin's fears proved to be true soon after his death. The laws of inheritance, discovered by an Austrian botanist, Gregor Mendel, caused Lamarck's and Darwin's assertions to collapse. The science of genetics that developed at the beginning of the 20th century proved that it was not acquired physical traits, but only genes that were transmitted to subsequent generations. This discovery made it clear that a scenario suggesting that acquired traits accumulated from generation to generation and generated different living species was implausible. In other words, there were no inheritable variations for Darwin's proposed mechanism of natural selection to choose from. Subsequently, the theory of evolution as advanced by Darwin has been collapsed early in the 20th century.
In Darwin's theory, if you think of the branching tree, Darwin's branching tree, the common ancestor down here and the different modern forms of animals up here, you would have one form to begin with, and then it would gradually diverge into slightly different forms and more different until you get the major differences that we see now. The problem with the Cambrian explosion is that all these major differences appear together at the same time, with no fossil evidence that they descended from this common ancestor.
This situation refutes the theory of evolution for sure, because Darwin wrote in The Origin of Species, "If numerous species belonging to the same genera or families have really started into life all at once, the fact would be fatal to the theory of descent with slow modification through natural selection." This fatal stroke that frightened Darwin comes from the Cambrian period, right at the outset of the fossil record. No fossil remains supporting evolution have ever been unearthed in excavations conducted in every corner of the world.